Good morning, everyone. As many of you know, I'm Mr. Byrne from Glenbard West High School in Glen Ellen, and Mr. Faribaugh from Albemarle High School in Charlottesville, Virginia is here as well. But I am certain that none of you are here to listen to us talk.
Exactly.
You are here because you're almost as excited as we are to hear from our guest, Dr. Frances Arnold. I want to give you a little bit about Dr. Arnold's background for those of you who are just logging on. Frances Arnold was born and raised in Pittsburgh, Pennsylvania, where she attended Alderdice High School. Go Dragons. If you're listening, we're excited to have you. She has a degree in mechanical and aerospace engineering from Princeton and a doctorate in chemical engineering from the University of California, Berkeley. She's currently a professor at the California Institute of Technology. In 1993, Dr. Arnold conducted the first directed evolution of enzymes. From our studies on these lessons, we know that enzymes are the proteins that catalyze chemical reactions. Dr. Arnold used the principles of genetic change and selection to develop proteins that solve some of humankind's most challenging chemical problems. The uses of her results include more environmentally friendly manufacturing of chemical substances like pharmaceuticals and the production of renewable fuels. For this work, Dr. Arnold was awarded the Nobel Prize in Chemistry in 2018. Good morning, Dr. Arnold. We're so excited to have you. Thank you so much for being here. How are you?
Oh, I'm well. Good morning, Sean. Good morning to all the students.
Thanks so much for being here. I'm going to just jump in. We have so many questions we want to ask. We just have kind of a nice free-flowing conversation here. But since the primary audience we have here is high school students, could you maybe just describe some of your experiences in high school chemistry or science or just what high school was like for you?
I have to say I wasn't terribly mature in high school, so chemistry was not my main priority. In fact, I didn't even take AP chemistry, which was silly. I should have done it. I took AP biology instead because it was easier. But I enjoyed that. As I say, this was an interesting time in high school because we were in the 70s and there was a lot of disruptions going on. And I know you students are going through a lot of disruptions, but we had protests. The cities were on fire from riots and protests. And going to school was a challenge. Getting on the bus every day and getting to school was a challenge. And then, of course, I was 16. So, so I know what you all are going through, and it's hard to focus. But the good news is there's lots of time to make up for it.
Right, right. Did you like science in high school, or was it just sort of another class that you took?
I was always really good at math and science. I felt that I got that, and it was easy for me to make it through that. So I just assumed I would do something quantitative or scientific.
Cool.
So it's funny, I've got 4 daughters, and some of them have majored in English. One's currently majoring in political science. But when you were at Princeton, how did you decide that you wanted to kind of specialize in engineering?
So I went to Princeton is one of the first classes that accepted women, and no one was taking mechanical engineering. So it was a little bit of my way to get into a pretty fancy school with pretty mediocre grades. And it turned out to work pretty well. But then there I was in mechanical engineering, and I really had very little knowledge of what mechanical engineering really was about. Most of us don't, right? When we go to college, we have to try different things. So I applied, I got into mechanical engineering, and then I found out it was fairly interesting and also had the fewest requirements so that I could study political science and English and lots of languages. It's important to learn different things and try different things. And I found what I finally, after about 30 years, I found out what I really loved to do was chemistry.
Yeah, that makes sense.
That's really cool. One of the things that I recognize a lot as I was researching about you is that your interests, like you said in your studies, were very wide ranging. Your Nobel Prize recognized that you kind of had this intersection between chemistry and biology. How important do you think it is today for a scientist to have a broad range of experiences versus a very narrow one?
I think both are okay. You can become very specialized. I personally think that having a broad range of experiences gives you the opportunity to recognize new opportunities at the interfaces of disciplines. And many of the great advances that are happening in technology do happen at interfaces, in disciplines that nobody even knows exist, right? Because they're created as we go. And if you want to be a pioneer, you can take on well-established problems, or you can choose a whole problem that people didn't even know was a problem. People didn't know that evolving enzymes was even a thing back in the 1980s when I first started trying it out. So there are different ways to go. Personally, I'm a little bit ADD, so I like to go from one topic to the next, and I still take courses. I'm taking human genomics right now.
And I think that a lot of students don't really understand exactly what research is like or what engineering is like. So, from looking at your work, there's obviously, it seems to me that that your research, because it has an impact and has a connection to making the world a better place, there are a lot of scientists out there who are doing more maybe theoretical research, or I'm just curious, I want to learn more, but maybe just talk a little bit about your focus and how it seems like the research that you've done for many, many years has been focused on very practical application. Just talk about that a little bit.
Well, again, I'm an engineer by training, and I build things that help people or the planet. I'm very interested in helping the planet. And as a child of the 60s and 70s, I grew up in a time when renewable energy was becoming extremely important. My first job was in solar energy. I wanted to use my quantitative skills, my engineering skills, to do something that would help make the world a better place. And I think I share that with a lot of young people today. We want to make the world better than the way we found it. My generation has not done a very good job at that, I have to say. But it's a worthy goal to do that. And being an engineer, I looked at problems where I could find solutions that were useful. And by the way, it's not useful unless someone uses it. Scientists love to say that what they do is useful, but if nobody uses it, it's not useful. And that's an engineer's viewpoint.
What are some of the next problems that you think are going to need to be tackled by people or by the young people that are listening to this?
Well, chemistry. Let's talk about chemistry. The best chemist on the planet, in the universe, is the biological world. Nature is by far the best chemist who can take renewable resources from the environment, carbon dioxide, sunlight, and convert that into living, moving, adaptive machines, right? Yeah. The chemistry is just phenomenal. And if we can learn how to do chemistry like that, either mimicking nature or the way I do it, using nature, reprogramming the code of life to do chemistry for human beings, then we have a chance of living a lot more sustainably than we have in the past.
That's great. That's great. And so do you have like a message for students when they're considering their futures, or either in chemistry or STEM, or just in college and in general?
Well, I certainly hope that you'll use, obviously you are AP students, you are interested in science, you have skills that make you able to absorb this complex material and do something with it. You can do a lot to help the planet by staying in science. Science and technology will provide the solutions that help us live sustainably. And that's a great way to use your skills.
I agree. All right. Well, I would say that, and again, feel free to tell us any other specific things about your chemistry or your research, but I'm going to ask you a question that's not related to science at all. Here we are spending a lot of time at home. And again, I thought I'd just ask you, are there any TV shows or movies or other types of at-home activities that you're currently spending time on that has nothing to do with your work in the lab?
Oh, well, of course, we are cooking. Everybody is nice. Cooking. Yes. It's chemistry that really improves life for people. So that's a favorite. But I love this Italian TV series called My Brilliant Friend. And I lived in Italy for a couple of years. When I was a teenager, I took off from college and moved to Italy for 2 years to work in a factory. I learned Italian, and I love watching this HBO series called My Brilliant Friend.
I think it does make sense that right now people are sort of becoming scientists as they sort of concoct, different recipes. I feel like for me, that's what I've loved about cooking and chemistry is let's mix stuff together and see what happens. Yeah, exactly.
It's much safer to do in your kitchen than it is in the lab, though, I think, right?
Exactly. Yeah. Yeah.
Well, the Italians love food. So blending Italian and cooking and all that, it makes for a very happy atmosphere if you're stuck at home.
I agree. I agree.
Exactly. Exactly. Um, well, Dr. Francis, do you have, or Dr. Arnold, I'm sorry, Francis, do you have, can you just talk to us a little bit about like the moment when you realized that you had something going with your discovery of evolution of enzymes, and like what was that like? Did you know what was coming? Was there an aha moment, or was it much more of like a progression?
I think there was an aha 6 months,
Okay.
which is a very short period of time. Of course, it took the rest of the world. It took me 6 months to recognize, oh, wow, I've really got it. But it took the rest of the world 30 years. So sometimes we're a little imbalanced, right, in our recognition. Yeah. But why did I recognize that evolution was so powerful? Well, first of all, that's the way that everyone has been designed. All the biological world is the product of this tremendously powerful design process. But I recognized it would be important for us and for engineering enzymes, because no one knew how to do that. No one knew how to go in and tweak an enzyme to make it better at what it does or make it more useful in a human application. So that when we made random changes, and evolution's all about making some random changes and then selecting the ones that are better, you learn from the experiment. You do a random survey and you learn from the experiment what the protein cares about, not what you care about, but what the protein cares about. And when I found out what the protein cares about, and I knew that no one else knew this, that all the rules that people had come up with were completely wrong, I said, I've got it, because I'm going to capture the secrets of this complex world and let it tell me the rules. And everybody's going to do this because no other process works.
Yeah, I would imagine that some people are motivated by the message of it can't be done or it's impossible. And I think for you, it seems like a lot of what your work, hinges on is, well, we've never given enzymes a chance to, work on this substrate. Let's see what happens. And then the enzymes surprise you and you say, well, there you go.
We had so much fun. Just 3 years ago, we made the first enzymes to make bonds between carbon and silicon. There's no enzymes in the biological world that do that. But all you had to do was just ask, and they said, sure. So we just found all sorts of proteins out there in the world that could make bonds between carbon and silicon if you gave them the right reagents. Nature is poised to do all sorts of new chemistry, for good and for bad, right? Because it'll break down your new antibiotic. But she'll also put together things in completely new ways if you just ask her.
Yeah. Well, I think it's a real credit to your persistence to kind of eventually silence the naysayers and say, well, you just have to keep at it and keep trying. So it's amazing I appreciate the consistency and the effort. And I think that hopefully that message we can send for our students is, yes, you are going to struggle, whether that's with chemistry or other types of subjects, but you, how you respond to that struggle and staying with it. And really just, that says a lot about, the ability to overcome some of these obstacles. It's great.
Well, I think that point is really important. Science is hard. There's nothing easy about being a scientist, but that's exactly why it's so much fun and why it's worth working at. It's hard for all of us. It's hard for me, for sure. Chemistry, oh my goodness, I didn't take my first real chemistry class till I was 25 years old. You guys, you students are lucky. You're getting some of these important concepts now. And it's hard, but it is so much fun.
Yeah, I think that's very true. That it's definitely worth it. Just kind of stick with it. So,
Dr. Arnold, how has technology changed your work? I imagine, you said 30 years ago, computers were a completely different thing. Video chatting like this, wasn't a possibility. How, has it improved it for the better, for the worse? I imagine probably a little bit of both, but what do you say to...
Communication technology has completely changed. All my original papers were typewritten and painful and all that. But what really changed in my life was this molecular biology revolution, DNA technology. And that changed. The first cutting and pasting of DNA was happening when I was a student. And I could see that there was a whole new world that was opening up. And this, you students, you should be looking around and thinking about, gee, what's the world going to look like? What are the capabilities that we're going to have in 10 years that, my teachers never even considered?
Right.
And to me, that was the ability to cut and paste DNA. And that was such a powerful development in technology that I was able to exploit and use to make new enzymes. That was what the most important thing to me.
And the fact
email
that,
is also very helpful.
and the fact that at some point you realize, no, I don't think we're going to go in and make these changes. Let's go ahead and let the enzyme and the breeding process, let that work it out. So like that.
Yeah. But that took high throughput screening. So that was technology as well that it wasn't available 10 years earlier.
Can you talk a little bit about the just the process of collaboration and how important that is? We spend a lot of time in classes, students working in groups or developing their ability to communicate with each other and work together on a problem. How has that impacted your career?
That is the most important aspect of running a research group. My group, as you noted, is highly interdisciplinary. We have computer scientists working alongside organic chemists, working alongside molecular biologists, and they all have to talk to each other. I find that if you hire nice people, people who know how to talk to other people and work together, you can build things that no one else can do. And also people enjoy working with each other. Sometimes they haven't had that experience before they come to my lab at Caltech, and they find out how wonderful it is to be able to throw out an idea and have improvements come back in this evolutionary process of creativity.
Right.
So you
it's
can
much
start
more
with
than
a bad
test
idea and turn it into a good idea.
Yeah. Yeah. So I think for students that if they think there's this stereotypical image of a scientist, it's much more than beakers and flasks and test tubes. It's about people, and it really should always be about the connections between people. I feel like with teaching, it's the relationships that we teachers try to build with students, and again, the relationships that that college professors and principal investigators build with their graduate students. That really is such an important part of the learning process.
No one works alone. No great inventions are alone, right? You build on work of others, and the faster you can absorb and connect to those other things, the more powerful your own contributions will be. And the people in your life, when it all comes down to it, that's the biggest product you can have. And I'm so pleased, to teachers who take time for their students, teachers who take time to understand what their students are going through and to help them make their way. Those are the people that have the biggest impact on our lives.
Well, we definitely appreciate you being here. We really are excited to have you. Sean, you want to ask Francis any other questions or anything else you wanted to?
Yeah, I just want to hear you talk about your research more and more. Like, what are you working on right now? That maybe we could understand. I don't know.
No, I want to expand the chemistry of the biological world. If you look in biology, you see all these marvelous molecules that biology knows how to synthesize because they, in some way, contribute to survival and benefit of the organism that invented them. Mm-hmm. But there's a large, but limited number of transformations that biology uses to assemble these molecules. On the other hand, go to synthetic chemistry, organic chemistry, and look at all the transformations that were invented by human beings. There are a whole huge number of transformations you can't find in the biological world, and vice versa. Mm-hmm. I would like to marry those two. I would like to bring human chemistry and make it DNA encoded. DNA encode all the transformations of organic chemistry. So you could just program a bacterium and replace all the organic chemists with bacteria. Why would you want to do that? It's because nature's chemistry is highly selective and clean. And you can put all these catalysts together in one bag. And they do everything simultaneously in one bag of water. That's chemistry that humans can't mimic. I mean, we can't master chemistry like that.
That makes sense.
If we could expand what transformations, then we could make all the molecules or a large fraction of the materials and fuels and chemicals that we need in our daily lives, just with clean biological processes. Maybe even starting from renewable resources like atmospheric carbon dioxide. Because biology knows how to do that. It's called a plant, right?
Right. So instead of trying to find this ultimate, platinum or rhodium or osmium catalyst, let the enzyme take care of business and do it in a very specific
enzymes
way.
know how to do all that with iron. Iron has all sorts of wonderful oxidation states and capabilities that we're just beginning to discover. And this is the other thing I want to say about the science. We're at just the beginning of discovery here. In AP chemistry, you learn a lot of things that people have known for a long time. Believe me, there's a lot of things that nobody knows and that are waiting. They're like little gold nuggets on the wall waiting for you to pick them off and discover them for the first time. The biological world is full of that, of those gold nuggets waiting to be understood and captured and used by humans.
That's a very powerful message. I think students do sometimes feel like science is all about facts and memorizing things, or that somehow I'm just acquiring knowledge. But I think the fact that, not knowing something really is a very powerful motivation to make you want to learn more about it. That's great. That's a good message.
Like the most exciting position to be in when you don't know something and say, oh, this is such a great opportunity to learn and to figure it out. And whether that's something that, maybe some other people do understand, or maybe it's something that nobody understands yet, is just an exciting feature to look forward to.
It's so much fun. I look at acquiring knowledge as like putting money in my pocket, right? It's like I find a dollar bill and put it in my pocket. But when you go and discover something, you can spend that dollar bill and you get remarkable things back. So it's worth investing in that knowledge so that you are able to recognize that gold nugget when you see it.
That's
it's
really
a very
awesome.
powerful message. Thank you. Thank you.
Thank you. I would love just like a quick minute on what your experience was like winning the Nobel Prize and going to receive it and all of that. I know, I want to respect all of your great work, but that would be a cool story for some of our students, I think, as well.
Well, as you may know, the greatest accolade of my life had happened last year when I was asked to appear on The Big Bang Theory. And I wasted a perfectly good morning filming the Nobel accumulation on The Big Bang Theory. But the second greatest accolade was being able to go to Stockholm in December 2018. I think it was about 10 weeks after I got the call. In the middle of the night, I was in a hotel room in Dallas when I got the call from Stockholm. And that was pretty exciting. Of course, no one answered the phone when I called it home. My children were sound asleep. So I think it took 4 hours. And then finally, my son says, "What do you want, Mom?"
A little bit of news to share.
Okay. Yeah. So one message is make sure you answer when your parents call you. Okay. Yeah. That's an important message for our students to hear.
No, it was so exciting. I went to Stockholm with 60 of my friends and family, 60. And former students from all over the world came. My family came, friends came, and we had one great party all week long. It took an entire week and we had such a good time. Everybody still talks about it. So my advice is if you ever get invited, you should go.
And with respect to Caltech, I would say that winning a Nobel Prize at Caltech means welcome to the club, pretty much. Is that how it works?
Oh, they're a dime a dozen. Nobel laureates. So the Wall Street Journal called me the next day and said, "Oh, what do you get? What do you get for getting a Nobel Prize? Do you get like a free parking space?" And I said, "Oh, no. If we gave everybody who got a Nobel Prize at Caltech a free parking space, there'd be no parking left." I'm the 38th. And there's only 300 professors at Caltech. 10% of our chemists have Nobel Prizes. Bob Grubbs, Rudy Marcus, Ahmed Zewail before he passed away. And there's only like 30 chemists at Caltech.
Yeah, so.
Yeah.
That's amazing. That's amazing.
So yeah, I'm just one of many.
Well, Dr. Arnold, we want to be respectful of your time, and we're so thrilled that absolutely one of the highlights of my life is going to be able to have a conversation with you and meet you and hear your words of wisdom. I know our students are going to do, so many great things in their future, and that we got to connect them with you is a really awesome part of that process. I don't know if you want to leave us with any parting words or leave them with any parting words before we sign off.
Oh, I just hope the students, first of all, that you get through this safely with your families, that you learn that chemistry. It will come in handy someday. And I hope that you'll go on and do something really rewarding for yourselves and for the world. We need you.
That's a great message. Thank you. Thank you very much. Thank you.
Thank you.
Such a great message. Well, students, that's going to be the end of our lesson for today. Thanks for joining in. We will be back tomorrow with some reviews of free response questions from previous AP tests, but couldn't pass up an amazing opportunity to talk to Dr. Arnold today. Hope that you'll go back and rewind this way more often than you rewind my lessons and listen to her words of wisdom. Write those down, put them up on posters on the wall, and we'll see you back here tomorrow morning. Have a great day. Be safe.